Hi everyone, my name is Gaurav and today I am going to present the simulation and analysis of E-Plane Sectoral Horn Antenna. In this presentation, I will explain what an E-Plane Horn Antenna is, how it's work, how we simulate it in HFSS, and what different antenna parameters means and why they are important. Introduction to horn antennas. Horn antennas are a type of microwave antenna that are derived from waveguides. A normal rectangular waveguide does not radiate efficiently. So, by gradually flaring or opening the waveguide, we create a horn antenna. This flaring improves impedance matching, directivity, and gain. Horn antennas are widely used in radar system, satellite communication, antenna testing, and measurement. Sec- Sectoral horn antennas are special types where the horn is flared only in one plane instead of both planes. E-plane sectoral horn antenna. Now specifically coming to the E-plane sectoral horn antenna. In this antenna, the horn is flared only in the E-plane of the rectangular waveguide. The dimension in the H-plane remains constant. Because of this structure, the beam becomes narrow in the E-plane and comparatively wider in the H-plane. This type of horn is used when directional radiation is required mainly in one plane. Typical application are point-to-point microwave links, feed antennas for reflectors. Now we are going to see the working principle of the E-plane horn antenna. The working principle is very simple. Electromagnetic waves are generated inside the rectangular waveguide. This wave travels toward the horn aperture. If the waveguide ends abruptly, there will be large reflection. But because of gradual flaring, impedance mismatching improves, reflection reduces, more power is radiated. The aperture size of the horn main, mainly controls gain, directivity, beamwidth. Finally, radiation occurs from the open aperture of the horn. Now this is the process you can see. Okay, so now we can see parameter to be extracted. These are the parameter we need to extract. Now we can see one by one. Okay. The first parameter is input impedance. Input impedance is the impedance seen at the feed point of the antenna. It has two parts, real part and imaginary part. For maximum power transfer, the antenna impedance should match the feed line impedance, usually 50 ohms. If impedance is mismatched, power gets reflected, antenna performance degrades. Therefore, input impedance plot help us understand how well the antenna is matched over frequency. Second one is return loss. Return loss or S11 tell us how much power is reflected back from the antenna. It is measured in dB. If S11 is less than minus 10 dB, the antenna is considered well matched. Lower S11 means better impedance matching, less reflection, more power radiation. So this graph helps us find the operating frequency range of the antenna. VSWR. VSWR stands for voltage standing wave ratio. It is another way of expressing impedance matching. Ideal value of VSWR is 1. Practically, VSWR less than 2 is acceptable. Higher VSW means large reflection, poor matching. Therefore, VSW plots confirm whether the antenna is properly designed at the desired frequency. Gain. Gain represents the ability of antenna to focus radiate power in a particular direction. It depends on directivity and efficiency. Higher gain means stronger signal in desired direction. Now directivity. Directivity shows how concentrate the radiation is in one direction. It is property of the antenna shape only, not considering losses. High directivity means more beam, more focused radiation. Efficiency. Efficiency is the ratio of radiate power to input power. It tells how effectively the antenna convert into input power into radiated waves. Now radiation pattern. Radiation pattern shows how the antenna radiates power in different direction. We analyze it in two ways: 2D pattern, 3D. As you can see the graph, there is uh, it is 3D pattern and it is 2D pattern. Polarization. Polarization refers to the orientation of the electric field of the radiated wave. Since this is an E-plane horn antenna excited by rectangular waveguide, it exhibits linear polarization. And understanding polarization is important to match transmitting and receiving antennas, avoid polarization mismatch losses. Now, what is the application we can have for E-plane horn antenna? They are mainly used in microwave communication links, radar system, satellite communication, antenna measurement setups as feed antennas for parabolic reflector. Their simple structure and high gain make them very useful in practical system. In conclusion, the E-plane sectoral horn antenna provide good directivity and moderate gain. HFSS simulation help us analyze all important antenna parameters effectively. This study help in understanding practical antenna design and performance evaluation. Thank you.